Number 31. A model airplane with mass 0.750 kg is tethered by a wire so that it flies in a circle 30 meters in radius. The airplane engine provides a net thrust of 0.8 newtons perpendicular to the tethering wire. A. Find the torque the net thrust produces about the center of the circle. B. Find the angular acceleration of the airplane when it is in level flight. C. Find the linear acceleration of the airplane tangent to its flight path. Okay, so for this problem, I started out by drawing my diagrams and labeling all the forces. In the lateral view, I labeled mg and tension, and the y and radial component of tension, and the thrust given off by the engine. And thrust is a force or push of a system in a single direction. And it's kind of hard to tell, but the thrust is perpendicular to the wire. I don't know if you can imagine that. And then I also labeled the radius. And this is the view from either the top or the bottom, but this is the thrust and the radial component of tension, and I also labeled the radius of the airplane's flight path. For part A, we're finding the torque that the net thrust produces. To do that, we use thrust is equal to R times F times sine theta. The R is 30 meters, and the force produced by the thrust is 0.80 newtons. The angle between the radius and the thrust is 90, so we plug that in for theta, and we get 24 newtons times meters. So for part B, we're solving for the angular acceleration of the airplane. So I summed up the torques and set it equal to the moment of inertia times the angular acceleration. And then I substituted the moment of inertia with m times r squared, and then I just isolated the angular acceleration, and so that equals the torque of the thrust over mr squared. And after plugging in the values, we find that the angular acceleration is 0.036 radians over second squared. And just a heads up about the units for that, a newton is equal to kg over s squared. And so when you're solving for the angular acceleration, your units would be n times n radians over m squared times kg, and when you cancel that out, you get radians over second squared. And the radians are from when you are doing torque and you have the sine of theta. For part C, we're finding the linear acceleration of the airplane. So we do linear acceleration is equal to r times the angular acceleration, and when we plug in our values, we find that 1.08 meters over second squared is the linear acceleration.